All right, guys, we're back with another example, except this time, instead of all gases, we're going to be dealing with solid here and a solid here. The only gas we have is O2. We ran this reaction. This is when we set magnesium on fire. It was a combination reaction, so we made magnesium oxide. If we balance this equation, I got 2 oxygens there, so we need a 2 there, and that means I need 2 magnesiums there, and we're ready to go. So looking at this, what mass of magnesium is needed to react with 5 liters of O2 at 1.5 atmospheres and 27 degrees Celsius? First order of business is we're going to use the ideal gas law to determine the number of moles of O2. That's our go-to first. So we get 1.5 atmospheres times 5 liters equals N 0.0821, never ever changes because it's a constant, and 273 plus 27 gives us 300, which means our number of moles, we're just going to do algebra here, our number of moles is 3.28 moles of O2. Now if you see this question, what mass of magnesium? That means we have to go back and really dig into our stoichiometry from the past. And so here, because now I'm going to have to shorten this word, and we're going to do a little stoich, we get 3.28 moles of O2, pulled that from my answer up here, times, well, we're looking for mass of magnesium, so I get 2 moles of magnesium over 1 mole of O2, and I get 6.56 mole O2, but we're looking for the mass of magnesium, and because we're looking for mass, we have to convert moles, it's not moles of O2, that was not good, it's moles of magnesium. We have to convert moles of magnesium into grams. So here we get 24.31 grams over 1 mole. And this 24.31, that comes from the periodic table, so it shouldn't be that hard to find. And when we do this math, we get 159.5 grams of magnesium. So that's how much magnesium you'll need. As we jumped on here, different problem, what volume of O2? So we're kind of switching up what we want to look at. At 250 Celsius, 1 atmosphere is needed to form 12 grams of magnesium oxide. Here, we're going to do our stoichiometry first. We get 12 grams magnesium oxide times, we have to get the molar mass of MgO, which is 40.31. So 40.31 grams over 1 mole. And that's going to give us 0.298 moles MgO, okay? And then from here, we're going to figure out how many moles of O2 we have. And what we get is 1 mole O2 for every 2 mole MgO. And when we do this, it's just 1/2 of this, which is 0.149 moles of O2. We're going to take that 0.149 moles of O2 and we're going to plug it into the ideal gas law. All right, and we're going to figure out the volume. So our pressure is 1, makes life easy. V we don't know, 0.149 moles, we just figured that out. 0.0821, that's our ideal gas constant. And our pressure is 250 degrees Celsius plus 273, which gives us 523 K. So once we go through and run through this algebra, we are going to get a volume of 6.4 liters of O2 gas. All right. What I'm going to do is I have some more examples on the Unit 9 practice. And I'm going to go through the answer sheet and I'm going to talk you through it. So look for those, they're going to be audio files, but look for those files on Canvas as well.